All right, so I've got a long list of these metrics. I'm not sure how many you would naturally think of, but let me list some, and then maybe you can riff with me.
Okay.
So one metric that we could use is, if we have an algorithm, does that algorithm identify the optimal arm in the limit? Like if you ran this infinitely long, would at the end of infinity, you know which arm has the highest payoff?
Okay.
So, well, that's good
Yes.
because it's good to know what the highest arm is, right? But it's kind of bad because this metric is actually achieved quite well by an algorithm that just round robin chooses all the arms. Pull the first one, pull the second one, pull the third one. So in the limit, we'll have all the data that we need to estimate them as accurately as we want, but we'll actually not have taken advantage of it ever.
Right. And so I think it's important to say then, right, that this is like the normal reinforcement learning setting. So while you're learning and doing whatever you're doing, you're still accumulating reward.
Yes.
Or not.
Right. So it would be nice to have a metric that actually paid attention to not just how much we're learning, but how much reward we're getting in the process. So we could just make that the goal.
Sure, but isn't that the original problem? I mean, how do you do that?
No. I mean, we were phrasing the original problem as figuring out which arm has the highest payoff.
Okay.
So this is kind of different than that, right? This is maximizing the discounted expected reward, which is going to to do that well. You should do some amount of exploration, but also some amount of exploitation. You're getting reward, but you also need opportunities to get high reward by identifying high scoring arms.
Yeah, sure. That makes sense.
Okay. So this is totally doable, except it's not so doable in that it ends up being, the computation for this ends up being somewhat intractable.
Oh, of course.
We could talk about how you can actually do this in practice. There's some special cases that actually work out beautifully. There's a thing called a Gittins index. So Gittins index is a way of saying, all right, here's an arm, and I've pulled it, some number of times in the denominator, and I've gotten some number of successes. These two numbers can be mapped to a value called the index, such that if you do that for all the arms, compute all their indices, and always take the maximum one, you actually maximize discounted expected reward. So it's this really clever mapping from the number of successes and the number of pulls to a number such that always greedily choosing with respect to that number is optimal.